Now we're going to apply the arc length formula to find the exact length of r equals 5 to the theta for theta going from 0 to 2 pi. Recall that our arc length formula is L is equal to the integral from a to b of the square root of r squared plus dr d theta squared times d theta. In this case, since r is equal to 5 to the theta, dr d theta is going to use the formula for differentiating an exponential with a base other than e. So we have the natural log of 5 times 5 to the theta. This goes into our formula directly, so we have the integral from 0 to 2 pi of the square root of r squared. Well, that's going to double the exponent, so 5 to the 2 theta plus dr d theta squared, so we end up with the natural log of 5 squared times 5 to the 2 theta d theta. Inside the square root, we can factor out 5 to the 2 theta, and we're left with 1 plus the natural log of 5 squared inside the square root times d theta. I want to point out here, natural log of 5 squared is not the same thing as the natural log of 5 with an exponent on 5. What we have is whatever the natural log of 5 is, that result is going to be squared. That's what this represents inside the square root. Well, we have here 5 to the 2 theta, which is a perfect square. So it comes out of the square root. I'm getting a little bit nervous about what's still inside the square root. We have the integral from 0 to 2 pi of 5 to the theta times the square root of 1 plus the natural log of 5 squared d theta. And then I realized everything inside the square root is a constant. It's just going to come along for the ride. As you may recall, the formula for integrating, or the integration rule, I should say, for an exponential with a base other than e brings in the denominator natural log of the base. So when we integrate 5 to the theta, we get 5 to the theta divided by the natural log of 5. But I'm going to write it with the constant 1 plus the natural log of 5 squared in the numerator. This will be evaluated from 0 to 2 pi. Our length then becomes the square root of 1 plus the natural log of 5 squared divided by the natural log of 5 times the quantity of 5 to the 2 pi minus 1. That's what we get when we put 0 in place of theta and 2 pi in place of theta. Going back to the original statement of the exercise here, find the exact length means I'm not looking for a calculator value. And so our length is the square root of 1 plus the natural log of 5 squared divided by the natural log of 5 times the quantity of 5 to the 2 pi minus 1.